Hey guys, it's Elton. Today, we're going to be talking about loops within Java. If you haven't already watched or learned about if statements, you can find a video about that topic on the channel. The first topic we'll be talking about is the normal while loop. A loop structure executes a set of statements over and over again until a certain condition set by the programmer is met. The format for writing a standard loop is just a while and then your condition in parentheses. Then below that you write the statements that you want executed. This condition must be a boolean. In a while loop, the condition is evaluated before the statements are executed. This means that the statements will not evaluate in the while loop if the condition is initially false. These booleans must have a logic operator. Logic operators are operators that you use to decide a condition. The ones that we are going to be using today are equals, less than or equal to, greater than or equal to, and not equal to. To demonstrate, I made a simple application that prompts the user for an integer under 100. Then it will tell us what to add to this integer to equal 100. It does this by adding 1 each time and keeping a track of the amount of times we've looped. The loop ends when the number is equal to 100. To keep track, we use a counter. A counter is a variable that increases by a constant amount. A standard counter would look something like this. Counters are used to, well, count. There's another type of counter called an accumulator. Accumulators are used to keep track of the sum of a number of values and would look something like this. Both counters and accumulators have to be initialized when they are declared like this. Back to the demonstration. If I enter 90, I should get 10. And there we go, we have 10. This demonstration also works with negative numbers. If I enter negative 90, then I should get 190. And again, we get 190. Then after the simple while loop, we have the do while loop. The do while loop is just a loop where the statements run before the condition is evaluated. A do while is written as do, and then the statements, and then while, and then your condition right after in parentheses. There are also flags and sentinels. A flag or sentinel is a value that triggers an exit from a loop. We try and make this a constant when we can. These are useful when you need to gather an unknown number of inputs. You can just say that the user can type the flag into the scanner and the loop will end. Here's an example of how to use one. In this application, I have the flag initialized to 0. I have a do loop that lets me collect values and then the condition evaluates. As long as I don't type in the flag, then the loop keeps repeating. If I want to collect 4 values, I can. If I want to collect 1, I can. Then the application displays how many times I collected a value, minus the flag. And then when I input 0, it should give me 3. There are also infinite loops. Infinite loops are just loops that continue on forever that often cause the application to freeze or stop responding. This usually comes from an error within the condition or the statements. These can be from do-while loops or while loops. Here's an example of an infinite loop. It is a loop where the value is always greater than 0, and the condition is also that the number must be greater than 0. This means that the condition is always true and the loop never stops. As you can see here, when I run the application, it just keeps going until I stop it or the application stops responding. And I'll stop it. The last thing we need to cover is the for next loop. The for next loop is basically a loop where you can tell it how many times to repeat. For next loops are typed like this. It's for, and then in parentheses, initialization, then a semicolon, then the condition, and another semicolon before how much you would like to increment the counter by. Then after that, you have the statements that you want executed. Within the for next statement, there's an integrated variable. This variable is only within the for next statement and will not be recognized by the application. Generally, people use the letter I, however, it can be anything. You could also use an already initialized variable, such as a number collected from a scanner, that would replace or leave out a component of the loop. An example of a for next loop looks like this. This one is just missing statements. So we have declared and initialized our variable I, and then we make the condition that the loop will only run while I is less than or equal to 10. After that, you can see our increment for our counter. Another little tidbit is that plus equals 1 can be substituted into just 1 plus plus, and the same can go for minus equals 1, which can be substituted into minus minus. So I made an example. This example just shows the numbers within the range of the number you input and a second number that you also input. I have my scanner and I have declared two variables that will collect the values. I prompt for and collect both integers, and then I have my for loop. This for loop doesn't initialize or declare a counter, as we are using one of our variables as a counter. The for loop makes sure that it only loops the amount of numbers that there are within the range of the two numbers by checking every time that num updates if it is less or equal to num2. Then we have the increment by 1, which should supply us with all the numbers. We then display all the numbers.